Welcome to the first episode of Swift by Sundell Swift Clips, a new series of shorter videos about Swift tips and techniques, starting with how we can make use of Swift's first-class functions capabilities. Languages that support first-class functions, like Swift, enable functions to be treated as values. What that means is that they can be stored as properties, they can be passed as arguments to other functions, and they can be returned as results from other functions. What this means in Swift is that functions can be used the same way as closures. Let's take a look at a few examples. Let's say that we have a view that we want to add a series of subviews to, in this case a button, a label, and an image view. In order to do that, we might use the forEach API, which enables us to iterate over a collection and get access to each element. In this case, we get past each subview, which we then add to our main view using the addSubview method. Now if we take a look at that addSubview method, we can see that it looks like this. It's a function that doesn't return anything and that takes a UI view as input. So it can essentially be modeled as a closure that looks like this. A UI view as input and nothing or void as output. Now that's really interesting because that's the exact same shape as the closure that we're currently passing into for each. We get a view in and we don't return any output back. So we can do this. We can simply pass our view's addSubview method directly as if it was a closure into our forEach call. Pretty cool. Next, let's say that we have an array of strings that we want to translate into URLs. Similar to how we used forEach in the previous example, we might be using compact map in order to perform that translation. We get a string in, and then we call URL's initializer, which returns an optional URL back. Again, taking a look at the declaration of that initializer, we can see that it looks like this. It takes a string as input, and it returns an optional URL as output. Again, it perfectly matches the closure that we're currently passing into compact map. So we can do the same thing as we did in the previous example, only here we're passing the actual initializer for URL into our compact map call. Because it turns out that Swift doesn't only support first-class functions for methods and other functions, it supports it for initializers as well, which is really cool. Next, let's say that we have an array of scores represented as integers that we wanted to sort in descending order, giving us the high scores. This could be done using the standard library's sorted API with a call that looks like this. What we do here is that we use a comparison closure where we are getting access to both of the elements that are being compared, and we return whether or not the first element should be ordered in front of the second one. Taking a look at a shortened version of that API, it looks something like this. It takes a closure which has the two elements that are being compared as input, and then returns a Boolean result. Now in Swift, operators such as the greater than operator that we're using here are actually also declared as functions. The operator we're using here looks like this. And interestingly enough, we can see that it has the exact same shape as the closure that we were using before. So again, we can go ahead and simply replace our closure with a reference to the operator itself, because Swift enables us to even pass operators as closures as well. Now finally, let's take a look at a slightly more sophisticated example. Here we're building a product view controller within an iOS app, which has a buy button, which has a closure-based API. Now when we are assigning a handler closure to our buy button, we need to perform this weak self dance. We have to pass weak self in and then use the guard statement to check whether self is really there before we start accessing its properties. And we're doing this because we're accessing self within a closure that is also retained by self. Since this closure will be retained by our buy button, and since our view controller then retains the buy button, we would cause a retain cycle if we don't keep a weak reference to self here. Now for readability, it could be argued that this could be better. So let's see if we can use first-class functions to fix this problem. What we're going to do is we're going to introduce a function called combine. This function is going to take any value of type A and combine that with a closure that takes A as input and then returns any value B as output. What it's going to do with those two pieces of input is that it's going to take the value that we passed and insert that into the closure to give us a new function that doesn't require any input. This is commonly referred to as applying the value into our closure. Now with this new function in place, we can go back to our product view controller and simply use our new combine function with our product and our product manager's start checkout method in order to create much simpler and more elegant code. What we've done here is we've turned a function that takes a product and returns void into a function that doesn't take any input at all, but still returns void, which makes it a perfect fit for our BuyButtons handler closure. Now, one thing that's important to remember when using techniques like these is that whenever we're referencing an instance method of an object, we are also retaining that object. So in this case, our product manager will get retained by this new function that we've created using combine. In this case, it's not a problem. Since we're not referencing self, we won't be causing any retain cycles here, but it's just something to keep in mind whenever passing instance methods as closures. That's first-class functions in Swift. You can find all of the sample code from this video at swiftbysundell.com/clips/1. Feel free to subscribe to this channel and also follow Swift by Sundell on Twitter to get notified when new videos get posted. Thanks so much for watching.